Hello everyone, I'm Keertana here from Sri Venkateshwara College of Engineering, currently pursuing my BE in Computer Science and Engineering. In today's topic, we shall learn about raster scan system basics in computer graphics. This comes under the subject Computer Graphics and Fundamentals of Image Processing. So let's get into the video and start with Introduction to Raster Scan Systems. Raster scan systems are a fundamental approach in computer graphics where images are displayed by scanning a series of horizontal lines called scan lines. Each scan line is composed of individual pixels creating a grid-like representations of the image. The next topic is addressing pixels in a raster. The first comes coordinate system. Pixels are identified by their x and y coordinates within the raster guide. The next is memory addressing. The frame buffer stores pixel data and each pixel's location corresponds to its address in memory. The next is mapping to display. The pixel coordinates are mapped to the physical display, ensuring accurate rendering of the image. Now let's see the advantages of raster scan systems. Flexibility. Raster scan systems can display a wide range of images from simple graphics to photorealistic scenes. Their efficiency. Specialized hardware and algorithms make raster scan systems efficient for more rendering and updating pixel data. Its compatibility. Raster scan displays are widely adopted, allowing for seamless integration with various devices and software. Their image quality, which is something to be talked about. Advancements in display technologies have led to high resolution, high fidelity raster scan displays. Now let's see about the pixel-based representations. In a raster scan system, images are represented by a grid of pixels, each with its own color and intensity. The resolution of the display is determined by the number of pixels in the horizontal and vertical dimensions, allowing for detailed and high-quality visual representation. Pixel-based representation is a fundamental concept in a raster scan system as it forms the basics for creating and displaying images on the screen. By manipulating the colors and intensities of individual pixels, we can create a wide range of visual effects and images. This allows for the creation of realistic graphics, precise rendering of text and shapes, and the ability to display complex images and animations. Understanding pixel-based representation is key to working with raster scan systems and exploring applications in various fields such as computer graphics, digital imaging, and visual arts. Next, we should learn about scan lines and frame buffers. So what is scan lines? In a raster scan system, the display is refreshed by sequentially drawing each horizontal scan line from top to bottom. This creates the illusion of a continuous image as the individual scan lines are drawn quickly enough to appear as a steady image. Frame buffers. The image data is stored in a frame buffer, which is a dedicated area of memory that holds the current image being displayed. Each pixel is represented by a binary number, which determines its color and intensity. The frame buffer allows for fast access and updating of pixel values during the refresh process. Synchronization. The scanline drawing is synchronized with the display hardware to ensure a seamless and flicker-free presentation. This means that the hardware waits until all the pixels on the scan line have been drawn before it starts refreshing the line next. This synchronization ensures that each scan line is displayed at a consistent rate, which prevents flickering and other visual artifacts. Understanding scan lines and frame buffers is important for working with raster scan systems, as they are the key components of the display process. By understanding how images are displayed on raster scan devices, we can create more effective and engaging visual contents for a variety of applications. Next, we have raster scan display devices. There are many devices. I've given you some of the devices here. For example, CRT displays. Cathode ray tube displays use an electron beam to excite phosphors on the screen. creating the desired pixel colors. LCD displays. Liquid crystal displays use a matrix of liquid crystal cells to control the passage of light, creating the image. LED displays. Light emitting diode displays used an array of LED lights to directly illuminate each pixel, offering high brightness and contrast. These are some of the really good devices which uses raster scan. Next year we have raster scan conversation algorithm. Scan conversation. Scan conversation algorithms are used to translate geometric primitives such as lines and polygons into the appropriate pixel values in the frame buffer. These algorithms determine which pixels should be turned on or off to accurately represent the shape being drawn. Initializing. Initializing techniques are employed to smooth the edges of rasterized shapes, reducing jagged or stair-stepped appearances. By using various algorithms and blending techniques, initialization can create a more visually pleasing and realistic representation of curved or angled shapes. Optimization. Optimization is crucial in real-time rendering systems where smooth frame rates are essential. Efficient algorithms are developed to minimize the computational load of raster scan conversation, ensuring that complex scenes can be rendered quickly and smoothly. Other techniques. In addition to scan conversion, initializing and optimization, there are other techniques used in raster scan conversion algorithms. These techniques include clipping, hidden surface removal, shading, and texture mapping, which further enhance the visual quality and realism of the rendered image. Next year, we have the applications of raster scan graphics. They are widely used in desktop computing. Raster scan displays are ubiquitous in personal computers, laptops, and mobile devices. They provide high resolution and vibrant visual experiences for various applications, including web browsing, document editing, graphic design, and more. Television and video. Raster scan technology is the foundation for traditional television and video formats. It enables the transmission and display of moving images, delivering entertainment, news, and information to millions of viewers worldwide. Video games. Raster scan graphics are the primary rendering methods for modern video games. They allow for immersive and interactive gaming experiences where players can explore virtual worlds, engage in thrilling battles, and enjoy stunning visual effects. We also use raster scan graphics in medical imaging. Raster scan techniques are used in various medical imaging modalities such as X-rays and CT scans. These technologies enable healthcare professionals to visualize internal structures, diagnose diseases, and plan appropriate treatment.